Hey everyone, let's jump right into this explainer. Today, we're unpacking a really fascinating solution to what is arguably the most high-risk vulnerability in medical transport. We're looking at a system that completely re-engineers how independent logistics operators document their work. It's doing this by blending highly specific physical hardware with completely automated software telemetry. The result is a zero-touch ecosystem, meaning the driver never has to push buttons or fiddle with screens to stay perfectly compliant.
But before we look at the exact solution, we have to ask ourselves, what actually happens in the blind spot between the transport vehicle and a patient's locked front door? In the specialized world of non-emergency medical transportation, this is exactly where catastrophic risk lives. We aren't talking about the drive itself here. We're talking about the exact moment the vehicle stops, the door opens, and the patient has to navigate varied, unpredictable outdoor terrain to get inside their house. It's a massive, unmonitored window of time.
So, here is our roadmap for the explainer. First, we'll look at the last foot liability. Second, the magnetic hardware mechanics. Third, geofencing and app telemetry. And finally, we'll pull it all together into the automated liability shield.
Section 1. The last foot liability. The unmonitored blind spot in medical transit.
Let's be real about how chaotic drop-offs can get. If a patient trips over a rug, or if an expensive piece of medical equipment gets dinged up along the way, standard GPS tracking isn't going to save you. You need actual eyes on the ground. Having a Bluetooth-enabled, cloud-synced video log is the ultimate cure here. Objective video verification completely replaces the nightmare of unverified claims. It's pretty much the only thing that can definitively protect independent operators and hospital networks from massive negligence lawsuits.
And that brings us to the actual definition of the last foot. This matters because without continuous audio and visual capture of this highly specific terrain, operators and hospitals are just left financially exposed. The last foot isn't just some catchy marketing phrase, it represents the absolute most critical liability gap in the industry. Think about it. Icy walkways, cracked concrete, steep porch steps, and the actual physical handoff. This is the exact environment that needs to be documented flawlessly.
Section 2. Magnetic hardware mechanics. Engineering the POVPP chassis for physical capture. Now, there's a huge contrast between traditional body cams and this new hardware approach. Traditional body cams are almost always mounted high up on the chest, right? But when a driver is helping a patient or pushing a walker, that high chest mount just shoots straight out at the horizon, or worse, directly into the back of the patient's head. It completely overshoots the ground. The POVPP, on the other hand, is designed to be worn down on the lower torso, inherently focusing the recording right where the actual hazards exist.
The core mechanics here are incredibly well thought out. This hardware isn't just comfortable for the driver, it's technically flawless at capturing 100% unobstructed data. Instead of those heavy, cumbersome harnesses that ruin uniforms, this uses a low-profile magnetic clamp. It's a 3-point array that literally compresses right through the shirt, meaning absolutely zero horizontal sway. Add in a resilient, elastically deformable neoprene sleeve with a permanently open aperture, and you get absolutely no plastic barriers causing lens glare or condensation to ruin the footage.
By placing the hardware specifically on the abdomen, the system uses a genius bit of physical engineering. It naturally frames the exact environment where slips and falls actually happen. The natural outward contour of the upper stomach acts as a mechanical wedge, tilting the smartphone forward. This fixed, downward anatomical tilt guarantees the camera is looking directly at the pathway, the steps, and the hand-centric task area. It completely solves that horizon overshoot problem we just talked about.
Section 3. Geofencing and app telemetry, the digital engine of the DischaRge ConcieRge app. Okay, so we have the physical hardware secured. Now let's look at the software, because the programmatic logic here is incredibly strict. When the driver is en route, navigating to the patient's home, the app is locked down in an orange mismatch mode. They cannot fake a drop-off, and they definitely cannot accidentally start recording early. But the absolute microsecond that vehicle breaches a tight 50-foot geofence around the destination property, the app flashes green. It instantly unlocks the safety checklist, and entirely in the background, it fires a Bluetooth command to wake up the smartphone camera inside that neoprene sleeve. The driver literally doesn't have to touch a thing.
The secret sauce making this work is the Haber-Seen formula. It's basically the invisible string connecting the software to the hardware, mathematically guaranteeing that a recording cannot start early and tickets cannot be closed outside the secure perimeter. The software actively pings the device's location, calculating the exact distance in feet to the target. If a driver tries to close out a drop-off from down the street, the API acts as a hard stop guardrail. It prevents the ticket completion and completely blocks the video upload.
And then there's the cutoff, 20 miles per hour. If the vehicle hits this exact velocity, the native device sensors automatically trigger a kill switch that definitively stops the recording.
This 20-mile-per-hour threshold perfectly acts as a safety buffer while sealing the unalterable video file. Think about the operational workflow here. The driver safely escorts the patient inside, locks the door, walks back to their car, and drives away. At exactly 20 miles per hour, the app knows, without a shadow of a doubt, that the vehicle is back on a public roadway and the drop-off is officially over. The app kills the camera and begins securely uploading the encrypted video chunks to the cloud. There is absolutely no fumbling with a phone while trying to merge into traffic. The system just knows.
Section 4. The Automated Liability Shield, synthesizing the physical and the digital. So, when you marry the hardware's downward mechanics with the app's incredibly strict telemetry, you instantly resolve the most catastrophic hospital risk scenarios. If a family claims a piece of jewelry went missing during a transfer, well, the objective video proves the driver never went near it. A slip-and-fall claim on a rainy porch? That downward-tilted camera proves the walkway was clear and protocols were followed. And because the video records continuously until the driver hits that 20 mph mark, you have a flawless, unbroken chain of custody proving nobody re-entered the home.
Because that invisible Bluetooth connection automates the whole thing, the driver doesn't have to think about compliance at all. The system simply packages the ultimate enterprise-grade audit log for them automatically. The moment a ticket closes, the platform generates a bulletproof cryptographic PDF. It bundles the safety checklist, the exact GPS distance from the target in feet, and a secure link to the video file. The driver gets to focus entirely on the patient's safety, while the app and the hardware silently build an absolute fortress of data around the transaction. For a hospital COO or a clinical risk director, the ROI on this is just massive. It's not just a neat logistics tool, it is an active risk mitigation platform that can literally prevent a multi-million-dollar lawsuit. The cost of running this software is basically negligible compared to the sheer financial protection of knowing exactly, objectively, what happened in that patient's living room.
I want to leave you all with a provocative thought today. As medical transport evolves, objective, automated verification isn't just some fancy upgrade anymore. It's an absolute operational necessity. The integration of that downward-tilted magnetic hardware, paired with precise 50-foot geofencing and 20 miles per hour velocity triggers, completely eliminates the guesswork from patient handoffs. It secures the driver, it protects the hospital, and most importantly, it ensures the patient's safety is verified. Thanks for joining me on this explainer. I really hope this breakdown gave you a clear picture of how hardware and software can perfectly align to solve massive real-world liabilities. So are your facilities' transitions operating on blind trust, or are they protected by an automated liability shield? Think about it.